Okay, good morning. Welcome to
MathForKids number 191.
MathForKids number 191. Oh, I was looking all over for the other brown marker and it was under the chair. Okay, so today I asked you what you wanted to talk about, and you said you wanted to talk about Sierpenski's triangle. That's fun, actually. I'm excited to talk about this, but where did you hear about this before? Because we have not ever talked about Sierpenski's triangle.
I just thought of it.
You just thought of it? Well, you must have heard the name somewhere. Do you know?
No.
Yeah, I don't know where you heard about this, but this is actually a really neat fractal. Do you remember some of the other fractals we've talked about?
The cope.
We've talked about the Koch curve.
Is that all?
Have we talked about the Mandelbrot set?
We have it on the iPad.
Yeah, we have that Mandelbrot set on the iPad. We've probably never done a video about it, but the Sierpenski's triangle is actually really neat. It's actually very similar to the Koch curve. So if you go back in some of our videos and search for Koch curve in Math for Kids, you'll see some neat videos. So what you do in Sierpenski's triangle is you always divide all of the sides in half, and then you connect them and take away the middle. Okay? So now we just take away the middle of this triangle. All right?
Yep.
Okay, and now what do you think we do next?
We divide each of these in half.
Now we have three more triangles, and we just do the same process. So will you do it with me? So will you do that triangle, and I'll do this triangle. Divide each of the sides in half, and then take away the middle. And divide each of these sides in half, and then take away the middle. All right, well that's pretty neat. So now we have a new shape, and ooh, I have an idea. Let's count the number of triangles we had at each step. Step one, we had just one triangle. The big triangle, right?
Yep.
Step two, how many triangles did we have? How many of the white triangles did we have?
It's 3.
We had 3. Okay. After step 3, how many of these white triangles do we have?
9.
9. Okay, so do you see a pattern 1, 3, 9? What are you going to guess for the number of triangles on step 4?
27.
Okay, what's the pattern?
Just keep multiplying by 3.
You just keep multiplying by 3. Okay, so let's do this carefully. So let's do let's do these triangles up here first. Divide their sides in half. Take away the middle. Divide these sides in half. Take away the middle. Okay, now let's do these triangles over here. Divide in half. Take away the middle. Okay, now let's do these triangles over here. Divide in half. Take away the middle, and then up here. Yeah, go ahead and do that one. Awesome. Now let's count and see if we have 27. So what would be a good systematic way to count these triangles? Okay. What do you think? To count the white triangles that are there, what would be a good systematic way to do it?
We could do it one area like this area and that area and that area.
Okay, so we could count each one of these areas, but what's an even smarter way to do it?
Well, we can figure out how much is in one of the areas, then multiply by 3.
Exactly, because all these areas are exactly the same, so once we figure out how much it is in one area, then we're just going to multiply by 3. Okay? Now notice that this area has 3 bits that are exactly the same too. So in fact, all we have to do is count these 3 triangles, multiply by 3 to get the number of triangles here. So we have 1, 2, 3. You see that?
Yeah.
So how many white triangles are in this bit then?
There's 9 in this.
9, and then how many white triangles are in the whole thing?
27.
27, just like we thought. And notice how that pattern, taking advantage of the symmetry, shows why we're multiplying by 3 every time. So what are we going to get next in step 5?
27 times 3, which is 81.
81, very good. So maybe we shouldn't take the time to do that because that'll take forever. Well, if we knew how to, have you ever seen the videos where they speed things up where people are going,
Yeah.
Yeah, I wish we knew how to do that in real life. Okay, but that's actually pretty neat. This is called Sierpenski's triangle, and you keep taking away the thirds. You can do this if you start with a line too, by the way. You can just take away the middle third of the line and erase it, and then take away the middle third of each bit, and then take away the middle third of each bit. This is called, I think it's called Fathouse dust. It's another fractal. But Sierpenski's triangle is really cool. And you know what else is neat? You don't have to start with an equilateral triangle. You can start with a different shaped triangle. Just keep dividing the sides in half and taking away the middle thirds, and you get these neat fractals. And they have neat little properties where you can count the sides, you could count how far it is around, or all sorts of stuff. You can count the area. It's pretty cool. Isn't that neat?
Yeah.
All right, high five. Good job. That was a great idea for a video today. That was really fun. Sierpenski's triangle.